increasing what? Wavelength.
Okay, so you can start now. I mean, I might even start then.
Start already. Look, look. Look, let's go.
Okay, this is order of decreasing. This is order of increasing what? Wavelength. That means this order is what? Decreasing wavelength. Why this order is increasing frequency and decreasing? Why their speed or V is constant. Are you understand? What's the speed of light? 3 point what? 3 times what? 10 raised power 8, Abi? Yes or no? Is it 3 times 10 raised power 8 what?
Yes.
Meter per what? Seconds. And if you look at what is here, you will see that particular trend. Do you get what I'm saying now? Kilo, this is kilo. Yes or no? So if you multiply it, so we are telling you that they are following the same pattern. So that's why we say that C is equal to V, that's constant. That C is equal to F1 lambda 1, and also it's also equal to C is equal to F2 lambda 2, which is a wavelength 2. So we can equate these two together if they are equal to C and C is equal to one another. Yes or no? So we have F1 lambda 1 is equal to F2 what? Lambda what? 2. So at that particular end, we have for the first frequency of the first transmitter is 200 kilohertz. I did not include that kilo here. Why? Because the other one is also having what? Kilo. So kilo will have cancelled out kilo. So we don't need that one. And that's why we remove all the units here. We already know our unit for what? Wave, for what do you call it? For speed, for frequency. Yes or no? So and we know our unit for wavelength. So anytime, any day, once we arrive at the answer, we put their respective what? Units. Yes. Okay, and that particular cost we have 200 multiplied by what? 1,500. As for first transmitter. For the second transmitter is 1,000 multiplied by what? Lambda what? 2, which is what we are asked to find. What is the wavelength for transmitter operating at what? 1,000 what? Kilohertz. So at that point, we have to make this one subject of formula. Lambda 2 is equal to what? 200 multiplied by what? 1,500 divided by the association here with coefficient here, which is 1,000. So 0 cancels 0, 0 cancels 0 here, then another 0 cancels another 0 here. Yes or no? What do we have left here? We have 20 multiplied by what? 15. Yes or no? 20 multiplied by 15 is what? 300. That's 2 times 15 is 30. This 0 here added to it, making 300. So we have what? Lambda 2 is equal to what? 300. What's the unit for lambda? For wavelength? Meters. 300 meters. That's how we get to that particular end. Do you get it? Assuming we were given this one in centimeter, we will get our answer in centimeter and then convert it to what? Meter. Or better still, we convert this one to meter from beginning and get our answer in what? Meter. So it's a straightforward thing. Any question associated with this again? Please. Yeah? Okay, sound wave. Is it sound wave? No, we've not yet done sound wave. Okay. Now let's go on to equation of a progressive wave. Can I clean?
Yes.
Please quickly write so that we can finish up. Hello? So that you will not sleep. Number 22. Oh yeah, read number 22 for me. Read it. Why noise over there? Oga, come. You will not hear anything. You will not hear anything. It's not there. It's live now. Now, please detail the question again. What's the diagram? Please let me. How many?
1, 2, 3. Yes.
Okay.
0.3.
Yes.
The diagram above represents a transverse electromagnetic wave
Please, let's write this question down. Represent what?
a transverse electromagnetic wave.
Wave, yes.
Traveling with speed 3.0 times 10 to the power 8 speed of light. Traveling with the speed of light.
Speed
Of light.
3.0.
Times 10 to the power 8.
Yes.
What is the frequency of the wave?
Frequency, yes.
Of the wave.
What is the frequency of the wave? Hey, everybody listen please. We are asked to look for the frequency of this particular wave with the diagram above. How do we solve for this? We all know that speed is equal to what? F what? Lambda, yes or no? And from the question, parameters given. Parameters given here, we have it that what? Parameter given, we have our C is equal to what? 3.8 3 times 10 raised power 8 what? Meter per seconds. Yes or no? And our F here is unknown. Our V, I say our V, our lambda is also unknown. Yes or no? Yes or no? Are we giving lambda here? The lambda is from two successive what? Crests to one another, or a full circle from one node, from a what do you call it? Three successive what? I say two successive, three successive nodes together. That means from here to here, from here to here. This one makes a full lambda where a complete circle is made. This one, a what do you call it? A trough curving inward, having a full displacement for one and another displacement downward for the other. We give you a complete cycle. Yes or no? And a complete cycle is the length of a complete cycle is what we call our what? Wavelength. Yes or no? So it's from here to here. How many of these do we have here? 1, 2, 3. Yes or no? Is it not 3? Let's go again. From here to here is what? That is from here to here is what? Lambda B. Then from here again to here is another lambda, yes or no? Then from here to here is another what? Lambda, yes or no? How many lambda do we have? 3 lambda, yes or no? So our wave distance is equal to what? Is 0.3 meter, yes or no? And this particular one is what? 3 lambda is equal to what? 0.3 meters, yes or no? 3 lambda is equal to 0.3 meters. Do you agree with that? No. Look at this here. They say that from here to here, everything is 0.3 meters. I get what I'm saying now? Do you get what I'm saying? And we know that distance between two successive crests is what we call our what? Wavelength, Abby? Our lambda, yes or no? And that means this is this, if this from here, if we have distance, this one, this particular half circle has been divided into 2, yes or no? That means this one is what? 1/4 of lambda, yes or no? This one is also 1/4 of what? Lambda, yes or no? That means we divide this one into 1/4 of what? Lambda, 1/4 of lambda. If you add everything together, I will give you 1. 1/4 in 4 places, is not 1? Yes or no? So that means if this one, 1/4 is what? 1/2. That means this place here, entire this place will be what? 1/2 lambda. Yes or no? This place is what? 1/2 lambda. This one is what? 1/2 lambda. 1/2 lambda, because they are the same half circle. Yes or no? 1/2 what? Lambda. 1/2 what? Lambda. Do you get the concept now? How many 1/2 lambda do we have? 1, 2, 3. So we have 6 multiplied by 1/2 lambda is equal to 0.3. Yes or no? 2 here 1, 2 here 3 lambda is equal to what? Do you get the concept? Yes? Eh?
Like, is the diameter involved in this question like this?
What is it?
Is diameter involved in the question?
Diameter. We can regard this one. See, listen to me. We are not. We cannot be talking about diameter in this particular case. When you start talking about diameter, you start bringing a lot of other ambiguity into your process. I get what I'm saying now. Eh? You get what I'm saying? That will now say that lambda is equal to 2d. I don't want to bring that one into this particular one. I get what I'm saying now. So we have this. At least you know how we get to this particular point. Do everybody understand this? What's it that you don't understand there? Eh? I can't hear you. You can hear me. Your noise is not disturbing my voice to you. Yet your own voice is being disturbed to get to me. Yeah? Okay, you can't hear me at all. Madam? I get this half lambda. Yes or no? What do we define wavelength as last week? The distance between two successive crests or two successive troughs. The distance between two successive crests, two successive what? Trough. Where is the crest here? Right here, yes or no? And that means if we sketch down to form our amplitude, we find that it has divided this half circle into what? 2. This one is a half circle, yes or no?
Yes, sir.
A half circle, yes or no?
Yes, sir.
So also, distance from here to here is now another, is now what we call lambda, yes or no? This one is divided into what? Another half, yes or no? How many of this kind of half do we have within this? You have 2. 1, 2. This one is a full one. If we divide it to look like this one, we have what? 1, 2, 3. Yes or no? If 4 of this is equal to lambda, that means each of them will be equal to what? Lambda over 4. Yes or no? It's just like we have one orange. We now divide it into 4. Each side will be what? 1 over 4, which is a quarter. Yes or no? So that is how we get to that point. So we have lambda over 4. Lambda over 4. Lambda over what? 4. Now looking at this particular full half circle here, how many lambda over 4 do we have here? Lambda over 4 plus lambda over 4. What will it give you? The LCM is 4, yes? 4 in 4, 1. 1 times lambda is what? Lambda plus, same thing here, yes or no? Lambda plus lambda is what? 2 lambda over 4, yes or no? 2 lambda, yes or no? 2 cancel 4 here will be what? 1 over. So if this is 1 over 2 lambda, every other half cycle too, they are not exempted. They are 1 over 2. How many of these do we? 1, 2, 5. So 6 multiplied by half what? Lambda. Can you see the board? So that is equal to what? 3 lambda. So that's how we got to that. 3 lambda is equal to 0.3 meter, because that's the whole length that we have been given there. Yes or no? Okay. Okay, in that case, we can calculate for what our lambda is from here. Yes or no? Lambda is equal to what? 0.3 meters divided by 3. Yes or no? And that will be what? 0.1 meter. So if we have our lambda to be 0.1 meter, we have our C is equal to what? F. What's our C? 3.0 times 10 raised to power 8 equals to what? F unknown multiplied by lambda 0. So our F will be equal to what? 3.0 times 10 raised to power what? 8 over 0. Which is something as what? 3.0 times 10 raised to power 8 multiplied by 10 raised to power 1 over what? 0.1 times 10 raised to power 1. Do you get my concept now? Okay, so that we will not be what do you call it, multiplying by and take 1, it will go up. I don't want anything to go up from here. Yeah, do you get the concept here? So what will this one be? Our F will be equal to what? 3.0 times 10 raised to power 8 times 1 is what? 9 over what? 0.1 times is 1, which is what? 3.0 times 10 raised to power 9 what? X. If you can get it up to this particular end, don't mind my way of calculation. Press your calculator too. Except you don't understand where we see C is equal to F lambda from. And I believe that we got this one from the gods. They were the one who brought it. Yes? Of 1. Why is it that 10 power of 1? Because we want to eradicate this particular decimal here. What's 0.1? Is 0.1 not the same as 1 times 10? Is 0.1 is not the same as 1 over 10? And 1 over 10 in indices is what? 10 raised to power minus 1. Yes or no? So before we can make this one to become 1, what will be 10 raised to power minus 1 times 10 raised to power 1? What will it be? It's not 10 raised to power minus 1 plus 1, Abi? That's 10 raised to power 0. 10 raised to power 0 is what? Anything raised to power 0 is 1. Yes? Do you talk? Yes? Why? Okay, see, listen to me. if you want a particular equation to still remain the same, especially a fractional equation, whatever you do to up, you do to the down, and whatever you do to one side, you do to the other side. Are you getting what I'm saying now? So now we have this here. We have this one up, this one what? Down. You get the concept now? So this one here, if we, let me leave it here. If we come to this point here and say that 3.0 times 10 raised to the power 8 divided by 1 over 10, yes or no? What does this mean? Is it not the same thing as 3.0 times 10 raised to the power 8 multiplied by 10 over 1? So what's 10 over 1? It's not 10 raised to the power 1. 10 times multiplied by 10 raised to the power 8 is what? 10 raised to the power 8 multiplied by 10 raised to the power 1 will give you 10 raised to the power 8 plus 1 indices, which is what? 10 raised to the power what? 9. Yes? Who is saying something there? Is it? You can do it now. That's what I've done the other time. Yes. You just press this and divide it by this. It will give you the same answer. Yes? You say what? Talk. They cannot allow them to do this. Yes, now that's the reason why I'm introducing all this. No, but if anybody don't want to understand, I mean, when we get there, you will be able to know what we are doing now. At least learn this now. Functions are not there. They have expected you to have your functions with you. I get what I'm saying now? Now, let's go on to what we call progressive wave. Progressive wave motion. We've defined progressive wave in the last class, yes or no? So today we are going to be looking at the equation associated with a progressive wave. And now listen, because if you miss the beginning here, you will start asking me, how come we got to this particular one? Sometimes it's just be that they will write the particular equation for you, and that is all. The equation will just be given to you, and that is all. But if you listen, maybe you can still relate a bit with your circular motion idea and be able to get what we are doing here. Okay, listen to me here. Progressive wave. Why? For a progressive wave of a particular angle inclination as it is moving from one end, transmitting energy from one end to another, y is equal to sine theta, or we say that y is equal to what? Cos theta, depending on where the theta is as against the amplitude. This is a progressive wave line where we have this. Yes or no? And so on and so forth if it continues. Yes or no? There is an angle at which it is moving here. Yes or no? Yes or no? And there is an angle that is here. Yes or no? Then if one angle is here, there is everything else angle 90. Is it not 90 degree? So there is an angle here. So along this particular one here, we have as against the amplitude here. This is what we call the amplitude. This particular distance from here is A. Yes or no? Yes or no? Is that not it? Okay. So in such a way that this particular theta here is the angle that can give us the reference in terms of horizontal. And if you look at this theta here, it's facing this horizontal, that's sine, Abi. Yes or no? But if you use this one here, it will be what? Cos. Yes or no? Do you get what I'm saying now? Depending on what you take as your theta. But the most probable one to take as a theta is this particular one. But for some people, Mulumbus, they can take this one. Are you getting what I'm saying now? In that wise, we say that that particular distance here, y, is what? Sine theta along this particular vertical level of y. But in terms of this, it will be what? Cos what? Theta. In terms of the wavefront, it will be what? Sine theta for this, cos theta for what? This. Do you get the concept now? Now, if two of them are equal angle sharing formula, like 45 degree, what will it be? Cos 45 and sin 45 is not the same thing. This is what I am drawing here. How many of you have seen projectile motion before? What's your projectile motion? In your projectile, we have this, yes or no? We have this. I said that there is a velocity. There is an angle it has here, yes or no? Now, in terms of the height, we have a resolution of this one in terms of y, in terms of what? X. What is this one in resolution in terms of y? Is it not sine? Y in terms of x? In terms of x is what? Cos. Yes or no? That's why we say that Vx is equal to u what? Cos theta. While Vy is equal to what? U sine theta. This is what we are doing here, for God's sake. This is the same thing we are introducing there. In terms of this particular vertical end here, we have it as what? U what? Sine theta. Do you get what I'm saying now? Okay. So that is why we say that for the equation of a wave, it can either be y is equal to what? Sine theta or what? Okay, let me say that when it is there, let me put x here because some of you still want that particular one, x. But we are not using our x. Our y is our major concern. Are you getting what I'm saying now? So y is equal to sine theta. Do you agree with that? But we remember in circular motion, our w is equal to theta over t in such a way that theta is equal to what? It's equal to w t. Yes or no? Do you remember this? So our y is equal to what? Sine w what? T. Do you get this now? Do you get this? Now, for a particular wave that doesn't start from the beginning, that you meet along the way, a wave is already ongoing before you start trying to associate it with it, what do you call it, information. That one is y is equal to a sine wt plus this particular one. This one here that you have here is the constant for a wave that doesn't start from origin. This particular one here is the constant for a wave that doesn't start from where? Origin. So we have this as that particular one, an introduction of the amplitude. So we have A sine WT is equal to this. And this one here, being that we are operating in a circular, what do you call it, motion, are you going to say now? In a circular path, is equal to 2 pi x over, which you know that we are going along the x-axis, abi? 2 pi x over what? Lambda.
So this is the example. You know, X is the X something, right?
Where should I come again from? Y is equal to A sine WT plus what? The face angle. Okay, you regard this one as just face angle, have you? Calm down. I'm telling it, calm down. You vibration. For every wave that is ongoing, as it has started, if it is, we don't have what to call an irregular wave. Once it has started, that particular, this, you will never see a point where this particular distance will be different from this particular distance for a transverse wave. Yes or no? This distance will be equal to this particular distance. Yes or no? It won't be equal. It will be equal. Yes or no? That one has introduced a constant in that particular pattern of motion. I don't understand now. It has moved for a while. Now we start assuming this is origin of this particular wave, and we do not meet it from the origin. We are meeting it here. How do we account for what has gone before? This is it. So we relate this as in regards to lambda. So our phase, what we call not phase angle, this is a constant for wave. I'm not using as phase angle here. This is the constant for that particular wave that has started, that did not start from what? Origin, that we met along the way. This theta, this particular sign is equal to what? 2 pi x over what? Lambda.
X has does X have a value?
S can have a value, just like your Y can have a value.
So S can have
I'm gonna say now, but the X here, as we know Y, what's our Y talking about? So what's our S talking about here?
So that means
That particular length.
So that means can have more than one value.
Yes, it depends on the wave that we are dealing with. It varies. You know, like you said, that wavelength varies. Yes or no? Yes or no? Frequency varies from one wave to other. Yes or no? Whereas what doesn't vary in terms of light is the speed of that particular light. Yes or no? Is that not what we say? It's WT. W is equal to theta over t. Do you agree with this? And if you agree with this, it's not difficult now. Theta is equal to WT. Instead of having theta sine theta here, what do we have? We use theta, you use WT to represent theta. Theta is equal to WT. So, but we are talking about for a particular wave that doesn't start from what? Origin. That we did not meet at origin. How do you make reference to it? Are you going to say now? A is equal to W, A sine WT plus what? This particular displacement. A constant form of displacement. That this one is equal to what? 2 pi x all over what? Lambda. How are we having 2 pi x over lambda? That's what should be your concern. When we were doing what this one the other time, when we were given this particular exercise, We did not divide by lambda. Didn't we divide by lambda?
Yeah.
So if we divide along this side by lambda, we have how many? We'll be able to know the number of circle that we have. Yes or no? Yes or no? That is 0.3 divided by 0.1. Won't you give us 3? How many complete circle do we have here? How many do we have here? That is what we are talking about. That what brought us to this particular. They don't just make, they don't manufacture equation. They don't manufacture it. It's not manufactured. Sorry. They don't just bring it and impose equation on you. They tell you the part where we are coming from. And that's why previous knowledge are always important to a particular topic. Now, I told you last week that it might be every time that we have to go back to circular motion all over again and start from there forward. Yes or no? So this one is equal to this, whereas 2 pi all over lambda is always regarded as the number of that particular wave, a constant number for the wave. For any wave, it is 2 pi all over lambda, which is what? K. This K is called regarded as what? Wave what? The wave number. A constant wave what? Number. So in that regard, where's our adjuster? Okay, in that regard, we have it that what? Instead of having 2 pi over lambda here, we bring it to here. Instead of y is equal to a sine what? Wt plus what? Plus what? Kx. Yes or no? Eh? Yes or no? You know our k. What's our k? 2 pi over what? So anytime you were given a particular number with this here, as a coefficient of x, you know that's k. And if you have to calculate your wavelength, you can bring that one out to use to calculate. And we all know that w is equal to what? 2 pi what? F. Yes or no? So our y is equal to a sine 2 pi ft plus what? 2 pi x over lambda. Yeah, sorry, lambda. Yes or no? What's common to both of them here? Eh? So we have 2 pi, Abby. Bracket what? A sine what? Ft plus what? X over lambda. So you can write the wave equation like this. We still have more ways to write it. Yes, bringing in back different parameters. So this one here is another. This one is equation. This one is an equation there. I gotta say now, it's still the same thing. Remember that W is equal to what? F is equal to 1 over T. Yes or no? Yes or no? Okay. So what we have here, Y is equal to 2 pi bracket A sine, instead of Ft now will be T over what? T. Yes or no? Yes or no? Plus what? X over lambda. Yes or no? This X is still over lambda. This one here, instead of using F, we use 1 over T. Abi, is that what you want me to find? Now remember that V is equal to what? F what? Yes or no? V is equal to what? What's our what do you call it? What's our F? What's our lambda equal to now? V over what? Yes or no? Is that true? Okay, if lambda is equal to V over F, let's bring this back. Y is equal to 2 pi bracket what? A what? Sine F over what? Ft abi plus what? Instead of this one now, we have what? V over F what? X. Yes or no? Yes or no?
No, yeah,
Eh? F over what? V, sorry. You are right. F over V. Do you get how we get to this point? This one is lambda. This is 1 over lambda. 1 over lambda will be equal to 1 divided by V over F. Yes or no? Is that what you mean? Eh? So what's this one will be 1 times what? F over V. 1 times F over V will be equal to what? F over V. Eh? What is it? Yes, now that's what we want to say. Y will be equal to 2 pi. F is common to both of them, abi? Bracket A what? Sine T, abi? Plus what? X over V. Eh? What's 2 pi F? 2 pi F is equal to what? W, abi? Y is equal to what? W bracket A sine T plus what? X over V. Or we say that Y is equal to what? A sine WT plus WX over V. This is another equation.
Location of the guy is what?
Kilo, sir? Eh?
Another one still there. There you go.
Back to sender. Okay, class captain, read. Okay. That Y is equal to A sine 2 pi outside, abi?
2 pi over.
2 pi over lambda now.
Okay. It's plus or minus X. And so this one is more value.
The problem they what do you call it, that they have there. Hey, now it's proving now. They brought A outside. EG as well. And
I'm not saying that this is not the limit that you have to know, like, they are just saying that it is the example of what you know.
Who is saying sir? Who is saying sir? Who is saying sir there? Yes. No noise, please. Write what's on the board before we continue.
Inside, like the face angle is also part of the theta.
And remember, see, they've introduced X here now.
Like the face angle.
Mm.
You know what? Right, you're writing how like they're bringing out the two parts. That it is sign. You do the sign of the two parts.
And now look at what is here. Look at what is here. Look at what is here. Y is equal to what? So look at this place. You are moving back. Y is equal to what?
So what I'm saying is that this sign.
Look at what is here first. And we said that Y is equal to what? A sine WT.
But what I'm saying is that the face angle.
Yes.
Is also part of it. It's like not the first theta.
They derive, look at how they derive this. Yeah, that's what I'm saying. You should look at it very well. This is for a particular wave. I get what I'm saying now. First thing is that they use the phase difference. I get what I'm saying. And find the equation for the what do you call it? Wave difference, phase difference as equal to this. This particular phase difference, the formula for phase difference is what they find as this.
But sir, what I'm saying is that
if phase difference is equal to this, if we drag it into this equation.
No, sir, like what you wrote now, y is equal to 2 pi, like the sign. Also
Oh. Yeah? That one is not a problem.
No, man. It's correct like this. It's here. 6WT equals to 2 pi financial PT. And then in equal to 2 pi.
Everybody look at me here. Look at this place, please. Everybody look at this place. The mistake is from here. Sorry, not from here. From here. We said that y is equal to what? Sine theta. Yes or no? Do you get what I'm saying now? Difference in angle will be y is equal to sine that theta minus or plus that particular this. Know that this both of them are in terms of angles. Yes or no? Yes or no? Both of them are in terms of angles. So I'm supposed to bracket them together instead of separating them. It is just here that I did not bracket it. That's why we are having what we have there. Our sign is supposed to always be outside with all these ones. A sign. Are you get what I'm saying now? Do you get what I'm saying? So coming back to this. Listen to me. Everybody look up very well. A sine WT. You know how I got to this particular point, Abby? Yes, or do you know how I get to this particular point? This particular WT is called to what? Theta, Abby? Yes or no? We have y is equal to a sine theta. That is for a wave that starts from origin. But for a wave that does not start from origin, we have this as what? Theta plus what? The phase angular difference. I get what I'm saying now? The phase angular difference. So that is theta plus this or theta minus what? This. It depends. It can be plus or it can be what? Minus. Depending on how the wave starts. I get what I'm saying now? So that's why we always put plus or minus, but we don't need that one yet. This is our major thing here. Do you get what I'm saying now? So we have theta is equal to WT plus what? This, Abi? Then this one is equal to this. I think we remember this, Abi? Yes or no? Bringing this for this here, this one here will be bracket. This one will be bracket. A sign will be outside, bracket what? WT plus what? KX. Do you get what I'm saying now? So in your whatever you have written, you don't need to cancel anything. All what you just have to do for me is to what? Bracket inward. All this one here. Then when you get to this place, this will be this. A sign will be outside. A sign 2 pi. 2 pi A sign this. Here also, here we have it as what? C over T, Abi? A sign. Do you get what I'm saying now? Such a way that we have Y is equal to A sign 2 pi bracket T over T plus X over lambda. We get to this particular point, it's still this. Get to this particular point, it's still this. You get what I'm saying now? How did you write this one the other time? Okay. 2 pi f, right? Do you get what I'm saying now? 2 pi f. So this one will also be 2 pi. Do you get what I'm saying now? Yes, it's still the same thing. Everything here is what still come outside to be this now. Oh. I get what I'm saying now. So Y is equal to W. It seems I've confused myself here. Let me go back to this. I know it's correct. Let me go back to this so that you will say. We have this, Abi. You know that we have this, right? Okay. Now look at this place. We said that F over V, yes or no? We have Y is equal to what? A sine 2 pi, yes or no? Bracket what? T over what? T, Abi? Yes or no? Yes or no? Plus instead of lambda over x over lambda now, it will now be what? F over v, abi? X. Yes or no? Yes or no? Okay, we said that the y is equal to what? What? Okay. Now y is equal to a sine this particular 2 pi here, 2 pi, this particular t is same thing as what? Ft. Yes or no? Plus what? F over Vx. Yes or no? So our y will be equal to what? A sine 2 pi f come outside bracket what? T plus what? X over V. Yes or no? So y will be equal to what? A what? Sine 2 pi f is same thing as what? 2 pi f is what? W. Yes or no? A sine W bracket what? T minus what? X over V. Plus, sorry. I told you that it can be plus, it can be what?
So it's really one.
Eh? 2.
One equation that I've not done.
Which one? Which one? Which one? Which one? Is it this one? Yeah. There is no one what? Lambda. That has lambda. No, we've substituted for lambda here. There is one that have lambda now. This one has lambda. This one has lambda. This one has lambda. We remove lambda by substituting for lambda here. I know what I'm saying now. We have one more. Call it out.
Y equals to A sine 2 pi.
A sine what?
2 pi. And over lambda.
2 pi over lambda, yes.
Bracket, bracket. VT plus.
VT?
Yes.
VT plus what?
Plus or minus X.
Yes, don't worry about that minus yet. I told you. Leave that one aside. Plus what? X. Yes or no?
Yes,
How did they arrive at this? It's still from this particular same equation that we have here that they arrived at this. They just want you to understand V is equal to what? F what? Lambda. Yes or no? V is equal to what? F lambda. What will our F be equal to?
2 pi.
That is V over what? Lambda. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Is that not it? Okay, we have y is equal to a sine. We said 2 pi f the other time, abi? 2 pi f bracket what? T what? Plus x over what? V. Yes or no? What's our V? F lambda, abi? Eh? Is our V not equal to F lambda? Eh? It is. So y is equal to a sine. Let's bring everything inside here. Bracket what? 2 pi ft plus 2 pi fx, abi? Over what's our lambda? This is, I say V, abi? Yes or no? Yes or no? Is that not what this one means? Is that not what it means here? If V is equal to F lambda, if you multiply this one out, won't it give you this? If that's what we have in there. We have what? Y is equal to what? A sine bracket 2 pi what? Ft. Yes or no? Yes or no? Plus, what's our V? 2 pi what? Fx over what? F lambda. Yes or no? F we cancel. Yes or no? Can this F cancel this F? No. So that some mulumbu will not say that you want to go and cancel it. So y is equal to what? A sine bracket 2 pi ft plus what? 2 pi x over what? Lambda. We have come back to the very beginning, Abi.
Yeah, lambda. So F can be V over
Yes or no? Now F is equal to what?
V over lambda.
F here. Make F solve a formula. F is equal to what? V over. Let's come back to this. So y is equal to a sine bracket. What's 2 pi? Instead of F now, we have V over what? Lambda, Abi. T plus what? 2 pi x over V. I say V. Lambda, yes or no? Yes or no? Bring these two together. Y will be equal to what? A sine. What's common to both of them? 2 pi over lambda, Abi. So we have 2 pi over what? Lambda bracket what? Vt plus what? X. Now, what's our Vt? What's our Vt? That is the distance. Is that our distance? So you can bring distance here. S plus what? X. That's all.
X.
Yeah? You write it now. Yeah? No, we can be given any equation anytime. Yeah?
I think it's give us the question.
2 pi f. Instead of having pi f here, f is different as v over lambda. Yes, that is for one equation. We derive for one equation. That's this one here. In case we are given angular velocity and we are not given what call it lambda. We are not given wavelength. So you can use this one to calculate based on the reason why you derive several equations is for you to be able to use it when they are being required. Yeah. Depending on the parameters you are given is what will determine the kind of equation to use. Do you get what I'm saying now? In case you have a particular parameter, look at the parameters you are given and look at the equation that correlates with the parameter set of parameters given. That is what we apply. Do you get what I'm saying now? Yes. Yes, now.
Oh, so let's go to the question. You know. Inside this, but before you can get all this thing, you want to know function and
Now let's look at a question on this. Let's look at questions associated with this particular formula that we have been given today. Question associated with this one. Associated, because I'm fast. Calm down. Okay. Don't let them rush you. They have advanced level there.
These are originals. I think there's one question in that past.
Yes. Please check for past question. Yeah. Can somebody listen to me, everybody? Look up here. I'm even seeing something there again. Can somebody remind me what we call 2 pi over lambda the other time? Is it not equal to k?
Yes, sir.
Oh yeah, bring it here. Y is equal to what? A sine k bracket what? Vt plus x. So I told you it can be negative too, depending on how the face angle relates.
So I've seen the question number 21.
Number 21, yes.
1990. Nice.
Question number 21, 1999.
Should I call it?
Wait, let other people get done. Quickly write up so that we can dictate the question. This your turtleneck did not touch well at the neck. Is it not turtleneck? It's not touch well at the neck. Okay, you like the this kind of turtle. This water turtle, right? He doesn't care about the note, man. Tell me. See him very well. Look at him. He's holding Rashida. I'm only reporting. Balumi, you know I'm here. I'm telling you the truth now. If you can turn the street fight, I will be available as referee. Eh? Don't fight the wrong person. Fight Inni. Yes. I should come over. The formulas are necessary. Even this face cap is for people who want to sleep. People who are planning to sleep from home, they are the ones who do wear this kind of face cap. They're able to see their faces. You want to sleep by style. You just came in now. See, you just came in now. And that's what I'm saying. You just came in now. See what you are doing. Yes. Are you with me? I believe no one is there again. What to do? Call the question. 1999. Yes.
21.
Okay.
The equation of a wavelength
Yes.
along the positive x direction
Yes.
is given by
Given by what?
y equals to 0.25 times 10 raised to power minus 3 sine into bracket f1xt minus 0.0025x. 00, not 0.
Yes.
Find determine the angular frequency of the wave function.
Hey, determine the angular frequency of this particular wave motion. Out of the equations that we were being given, which one out of them looks like this particular equation? Y equals to what? A sine what? Into bracket WT minus KX. Yes or no? This is the one that looks like this. Yes or no? Is it not the same one that look like this? Other ones, they having lambda over X here. Do you have anything like lambda over X here? Okay, if you want to bring them in, you will find out that you have 2 pi over lambda will be what will be equal to this. Yes or no? So when we say that you look for angular frequency, we already know what will give rise to frequency here. Yes or no? Egba.
Please. FPC.
It will stay. Okay. Now, given what? Equation, yes.
Y side into bracket 2000 by t minus 0
Pi t, right? Minus what?
0.4x.
Okay, let me write the equation here. Y is equal to 5 sine
Bracket 2000 by t
minus
0.4x. 4x. Calculate the wavelength.
calculate the wavelength. Hey, you have to calculate the wavelength here. The same equation like before. Y is equal to what? A sine bracket what? 2 what? Pi what? Ft, abi? Or Wt minus what? Kx, right? What's our K? We have a 2 what? Pi x over what? Lambda. Yes or no? Remember, what we have to calculate is what we are bringing out there. Yes or no? Which is this, Abi? Yes or no? Or we say that kx. You look kx there, yes? That is what do you call it? Our angular velocity, which is 2 pi ft. It's 2000 pi t now. This one is 2 pi f. Listen, 2 pi f is equal to what? Is equal to 2000 pi. So pi cancel out pi. 2f is equal to what? 2000.
F equals 1000.
If you have to calculate f, that's not what you have to find. So f is equal to what? 1000. Yes or no? While here, our k is equal to 0.4, abi, which is equal to 2 pi over what? Lambda. Yes or no? What? Listen, when we have 2000 pi t, 2000 pi t is same thing as 2 pi f now from the equation. Our major identity there, madam, our major identity is t there. What's coefficient of t here? 2000 pi. And in normal equation, it is what? Is a sine what? A sine bracket wt, abi? What's our w? Is what is the coefficient of t? What's coefficient of t? 2 pi, 2000 pi t. 2000 pi. Do you get the concept now? Yes? They're asking us for wavelength. Is that what wavelength? What was the question? So this is our major thing. What's the wavelength? We all know this one, right? Our lambda is equal to what? Which is equal to what? 2 pi over what? Lambda, abi, is equal to what? 0.4, abi. So our lambda will be equal.
Now come again.
2 pi over lambda is equal to 0.4. And I place it back here. This is equal to this. God, is this one not equal to this?
okay as K.
K is equal to this, Abi. Wait, K is equal to this, Abi. Is K not equal to this? Yes. Talk. This one here is something as A sine bracket WT minus what? Minus KX. Yes or no? So what's K here? So K is equal to 0.4 and K is what? 2 pi over what? Lambda. Is that not it? What are we have to find? It's not this. That's why we have to use this. You cannot find this one without, you cannot find this without using this. Because we have to see equate K to be this. And if K is equal to this, then everything is equal to this. 2 multiplied by pi is what? 3.142 over what? 0.4. Yes or no? That's lambda is equal to what? 20 times 3.142 Abi over 4. Yes or no? 20 times 3 is what? 20 times 6 is 5 times 2 in 4 20 21 Abi. 5 times 1 plus 2. 5 times 3 plus nothing. So lambda is equal to what? 15.71 what? Meters. Yes. What's the question? Okay, no, we answer it now. I said I've not taken question from their side before, so it not look. What's that word?
So we take our equation from the equation.
This one?
So we take our formula from the equation.
That means what is here is equal to what is here. Abi? 2 pi, 2000 pi t is equal to 2 pi ft. Yes or no? T cancel t out. So 2 pi f is equal to what? 2000 pi. Pi cancel pi out. 2f is equal to what? 2000. What is it? 20. How did I get 20? Okay. This is 0.4. It became 4. You get it now? No, you people are using calculator. I'm not using calculator here. Any question? Okay. Can I clean this one at the center here? Can I clean this? Who said wait? What are you still doing? Next question, please. Dictate. Are you getting it? How do I get my 20? This is 0.4 here. This is 4 here. Look at this place. This is 0.4 here. This is 4 here. You do not say how did I get 4 here. You understand it? 0.4 became 4. That means we multiply by 10. Multiply up by 10 too. That is 2 multiplied by 10, making 20. You just have to be fast with things. That's the reason. Hmm? When you are seeing the equation, you are not seeing it as the way everybody will see it. Dictate your question, please.
Next time.
Yes. Along what? Yes. Y and X are in what? Hey, everybody look up. What do you mean by maximum displacement? What by maximum displacement from equilibrium position? What do you define that one as last week? What do you define as maximum displacement last week of a wave from its equilibrium position? Amplitude. So what we have to look for here is A, and we have Y is equal to what? A sine what? Open bracket what? WC plus what? Kx, abi? So we can say that Y is equal to A sine bracket Kx plus WT. Abi, calm down, wait. I told you that this thing is either plus or minus. Yes or no? So we can also write as Y is equal to what? A sine bracket what? Kx minus WT. So what we are saying is that whenever we are to make identity here, our sign here is not going to give us any much concern. Our what? Sign here is not going to give us what? Any much what? Concern. If our sign to give us concern, all what we have been doing here, we would have said that what do you call it? This one here is minus 0.4 is equal to this. And that will have been giving us concern. You get what I'm saying now? So what is just creating for that sign is to create the direction of the vectors. The direction of the what? Vectors. Either they are both in the same similar direction or what? In opposite. As simple as that. Now, in this particular wise, we all know A. What's our A? According to 0. A is equal to 0.3. What will now be the unit of A? Unit of A is in meter, but they gave us something here. Where Y and X are in what? And when you draw your wave again, this is Y, this is what? X. So talking about the maximum displacement, this one is in centimeter. What's this maximum displacement? Centimeter. Answer. There is a reason you must follow it. Yes.
Okay, why are yes,
If they say that if where Y and X are in meters, this one will be equal to 0.3 chicken. Eh? You have not yet answered it too. Is this the answer? Yes, if your answer now is now giving a meter in your options, you know what to do. I'm saying it. If they now say that you should find it in meter, just know what to do to this. Because already the person has stated it clear that this one is in centimeter. If they now still give you answer in meter or any other unit, know how to convert this back to those ones. It's not difficult. I told you that anything dealing with wave equation is a straightforward equation. Where we are to start having problem with wave in terms of a bit of calculation is when we keep on delving into what we call a refraction, light, sound wave, a bit. When we talk about harmonic, some of you when we get to harmonic now, you will start questioning why do we have why do we have why you start giving me questions. So just calm down. We are not rushing ourselves. At the same time, we cannot be too slow. I get what I'm saying now. So use the right on time. Quickly copy up so that when I want to clean, I'll be able to clean on time.
I'm done.
Hello? Check for another question there. Check for another question there. Yes. Previous one, yes. Okay. Please help me. Help me with it.
One there. It's one there.
Yes.
Now.
Okay. Yes. Here now.
That is very considerable.
All smokers are liable to live long.
Hey, how about I'm saying?
Now, this one now. I don't have to.
No.
Okay. Is what? Let's leave it outside here for the sake of problem.
Let's find the frequency.
Okay. Now everybody look here. Let me explain this before we take the question, so that some of you can be able to attempt the question on your own. I get what I'm saying now. Let me tell you this. This particular wave is moving in this direction. Now we were given cutting this into half. That is 1/4 abi lambda. Yes or no? Quarter of a lambda is equal to 0.01. That is in meters. I get what I'm saying now. Why they say that from air to air it takes 0.1 second to air, that is another plus 0.1 seconds, that's 0.2, 0.3 for every half circle, 0.1. How many half circle do we have up to this point? One. How many half circle? 1, 2, 3, 4. So that is where we have 0.4. So my concern doesn't run much. My concern doesn't go too far. My concern is even from the first one, and I am done. What are you to calculate? Driving on a just the what? Frequency. We have to find F. Yes or no? What's our F? In relation to lambda, F is equal to what?
C over lambda.
Is equal to V or C over what? Lambda. Yes or no? Is that not it? Do you agree with this? But our V here, our F is not here, our V is not yet known here. How do you know our V? Our V is equal to what? Distance over what? Time. Yes or no? Where did we give up distance up to? From here to here. Yes or no?
Yes.
What is that particular distance to this particular point? This 0.101 abi, another 0.01. What will be these two full cycle? 0.02. How many do you have? 1, 2, 3, 4 times what? What will that be? 0.08 is equal to S. So what will that be? S over 8 is what? 0.08 over what the time taken to reach there? 0.4. What will that be? That will be what? This one cancel one decimal place out. Yes or no? This one cancel one decimal place out. 0.8 divided by 4. 0.2 meters. If you have problem with that, press your calculator. If it doesn't give you this, then start questioning. But if it gives you this, just keep quiet. This is the question. Where is the question? What's the question here? No, I want the question. Yes, what's the question? You are looking for frequency. It is the frequency that led us to all this. I don't understand now. Do you get it? So we have lambda over 2 is equal to 0.02 meter. Yes or no?
Yes.
Are you understand now? How many lambda over 2 do we have here? 1, 2, 3, 4. So we have 4 times what? Lambda over 2 is equal to what? 0.02 multiplied by 4.
Why is it 0.02? So look at it now. Lambda is a circuit. And that one is outside. That's a quarter circuit is 0.01. So the circle is 0.04.
Did you place full lambda here? This is lambda over 2. It's a full lambda from here to here. That's lambda. So how many do you have? 1, 2, 3, 4. 4 of this is what?
0.04.
0.04. How many do you have here? How many lambda do you have here? 1, 2. Times 2 is what? 0.04 times 2 is what? Yes? Yes? You don't understand? Are you seeing this? This is a wave motion now. They draw a wave motion out for us to identify something from the wave motion. Now, they said that the wave motion shown above has the frequency of dash. Look at me here, leave that person alone. You are the one asking question, leave her alone. If she doesn't want to, when she's ready, maybe she will now come our attention. And if I have the chance, I will still. We have 0.01 here. What is the meaning of this 0.01? A circle is divided into, a half circle is divided into another 2. That is divided into half again. Half into half, that will be what? Over 4, Abi. And we said that for a full circle is what? Lambda. Distance covered by a full circle is what? Half. Yes or no? It's lambda, sorry. Abi? So if we have half of it before, half of lambda, I what I say now, which is this, will be what? 0.01. Abi? Half of lambda will be equal to what? Will be equal to half circle, Abi? Because of half circle distance. So if we have half lambda is equal to half circle distance, we are now given that half of that particular half. What will that be? Half of that particular half is what? 1/4 lambda. Yes or no? We've written this one in the previous question we've done today. Quarter lambda is what we are having here. What's your quarter lambda? Is 0.01. Yes or no? Now for our wave distance, how many quarter lambda do we have in there? This is from here to here that we have a specific time covering for. Yes or no? From here to here. How many half do we have? We have 1, 2, Abi, 3, 4, Abi. This will be 5, 6, Abi, 7, 8. That one is what? 8 multiplied by 1/4 what? Lambda, Abi, which is equal to what? 8 times what? 0.01. That is our what? Distance. 8 times 0.01 is what? 0. What? 0.08. 0.08. That is what we have as our S here. So if you know X, we've said it before that our V is equal to distance over time. What's our distance over time? Is 0.08. 0.08 divided by 0.4. I said one decimal place, we cancel one decimal place. We remain how many decimal place here? 1. This one, no decimal place at all. That is what? 0.8 divided by 4. That is what? 0.2. If you press your calculator and it's not equal to this, pressing this, that's when you should ask question. But if it is equal to this, just keep quiet. I what I'm saying now? So that is what we calculated here. And this is not where we are going to fully. We are coming to find what? F. And F is equal to what? V over what? Lambda. Yes or no? Yes or no? Is what? V over what? Lambda. If quarter lambda is equal to 0.01, what's one full lambda? Lambda itself. If we have 1/4 lambda to be equal to 0.01, Abi? Is it 0.01? 0.1, Abi? 0.01, Abi? Yes or no? What will this be? Lambda will be equal to 0.01 times what? Which is equal to 0.04. Yes or no? So what's our F? Our F is equal to what? 0.08 divided by what? 0.04. Yes or no?
Like 0.2 by 0.2.
Oh, 0.2 Abi? Yes or no? Is equal to this, Abi? Now this divided by this is what? This divided by this is what? Is it 5? That is what? 5 what? X.
What do you make use of one language? Who you?
Hmm? What is it? What is it? I don't understand. You don't just.
You are telling us that one second, like one another. Like the next people that want to be one another. But that is the second. You calculate to one another.
What is a lambda here? What's a lambda? Is this not one lambda here?
Yes.
So what is eh? Is it 1/4? That is 1/4 lambda is equal to what? What will be lambda? 0.1 times 4. That is 1, 2, 3, 4. That is equal to 0.04. That's lambda. And we have find our v to be equal to this. We don't need this second lambda now. Lambda is lambda anywhere. I get what I'm saying now? Listen, it's not different. Look at me here. What we have here from this place to this place is our timing.
So, sorry, so you don't say like 2 lambda equals 0.0.
Oh, this place is 0.2 meter per second.
What I'm trying to say, like, you like 2 lambda equals to yes, and 2 lambda equals to
The same thing where we did here now. I can't tell you. Yes. Hey, listen to me. If anyone is having problem with it, before I will give you a shortcut. Listen to me. Do you understand this? Right in this question, you don't need to go through all these particular. But if I do it straight, people will still ask me question. I've not yet done shortcut. You are still asking question. Let alone when I go to shortcut. The shortcut here. What is a frequency? No, what is frequency? Time taking. Amount of what? Oscillation completed in what? 1 what? Seconds. Amount of oscillation completed in what? 1 seconds. If for 1 circle here, look at this that particular place. For 1 circle here, time taken to complete 1 circle is what? Time taken to complete 1 circle is what? Time taken to complete 1 circle there from the question there is what? Is is equal to 0.2 seconds. Yes or no? And according to our definition last week, time taken to complete 1 circle is defined as what? Period. That means our t is equal to 0.2 seconds. What's our f? X equal to 1 over what? T. That is 1 over 0.2. 1 over 0.2 is not the same as 10 over 2. We got 5 hours. Hey, listen to me very well. If I give you this shortcut, hey, listen, do you know that we have some people here that have not done anything like this before? We have some people here who have done it 1,000 times. A lot of people here have done it just 2 times, 3 times. All this contributed to why we have to go through that. Hey, people are complaining. Yeah, I just give us the recut now. Abi, if you want to give us the, no problem. I will give you the record next. If you now ask me question, that's when I will remove your head. That is when I will remove your head. What? I can't tell you. They gave us these particular values inside 0.1, 0.01, 0.1 here, and they place it here. That means these ones are the one in time, which is second.
No, when I did down, it was 2.5. It was 2.5, and I forgot to ensure that
I did not use my belt until you agree. Any question again? Any question? Are you getting it? Any question? All over. Where are we now? Now let's go on to sound wave. What was it by your time?
So that's the question.
Hey. Okay, let's take this question then. Objective questions. Shop life. Okay, dope life vet, okay.
If the time to complete the absence with us, it is 0.2.
Time to complete one business.
Yeah. Okay, now let's take this question now. Everybody. A stone. A stone. Okay, now please let's answer it just objective. Let's answer. A stone. No, not 75 years ago. A stone is dropped into the middle of a pool of water. Full stop. Which of the following statements is or are correct? A. Spherical wave are set up in the water. Is or are correct? Roman figure 1. Spherical wave are set up in the water. Roman figure 2. The water move outward to the side of the pool. 3. Energy is transmitted outward from the center of disturbance. Roman figure A now. No. Option A, 1 only. Option B, 2 only. Option C, 3 only. Option D, 1 and 2 only. Option E, 2 and 3 only. Option F, 1, 2, 3 all. Huh?
Water moves out of sight. Yes.
Which one is correct? Spherical waves are set up within the motion.
Yes.
The water move outward to the side of the pool. Is that the water? Is that water moving? It is wave.
I actually choose one.
Do you get it now? Water is not the one moving, it's the wave that is moving. I get what I'm saying now? It's the wave that causes the ripple effect. I get what I'm saying? So it moves from the center, it's transmitted outward. I get what I'm saying? It's just disturbing the particles and the move. Do you get what I'm saying now? Energy is transmitted outward from the center of disturbance. That is the energy movement. That's wave energy. That is what you are seeing that is forming that particular spherical movement shape that makes it to. I get what I'm saying now? You get it? You don't get it, you do what? Yeah? With these few points of ours, we have been able to what? Thank you so much. Okay. Whoever here pani.